My name is Shalyn Combs, and I'm doing my number 6 discussion video on the brainstem respiratory centers. The automatic unconscious cycle of breathing is controlled by 3 pairs of respiratory centers in the medulla oblongata and pons. And we know where those are from the past chapters. We have the pons, and then we have the medulla oblongata. The automatic unconscious cycle of breathing is controlled by 3 pairs of respiratory centers in the reticular formation of the medulla oblongata and the pons. Under the medullary center is under the medulla, we have the ventral respiratory group, or VRG, and the dorsal respiratory group, the DRG. So I'm going to focus on those two first. The ventral respiratory group is the primary generator of the respiratory rhythm. It is an elongated neural network in the medulla with 2 blended webs of neurons, the inspiratory I neurons and the expiratory E neurons, and each of those form a neural circuit that's repeated several times. In quiet breathing, called the eupnea, the I neuron circuit fires for about 2 seconds at a time, issuing nerve signals to integrating centers in the spinal cord. The spinal centers relay signals by way of the phrenic nerves to the diaphragm and by way of intercostal nerves to the external intercostal muscles. And the intercostal muscles are here, and the phrenic is right there. Now, the phrenic nerve is critical for the respiratory system to aid in breathing because it's the only nerve in the nervous system that provides motor functions to your diaphragm. And it sends signals that cause your diaphragm to expand and contract. And these movements cause your lungs to inhale and exhale. So that's that. And so, yeah, that's pretty important for the respiratory system. Okay. Contraction of these muscles enlarges the thoracic cage and causes inspiration as long as the I neurons are firing. They also inhibit the E neurons. Eventually, though, the I neurons stop firing either because they're tired or because they're inhibited by signals from the outside source. As their activity wanes, the E neurons begin firing. They further inhibit the I neurons, allowing the inspiratory muscles to relax. Elastic recoil of the thoracic cage expels air from the lungs. Relaxed expiration normally lasts about 3 seconds, and then the E neurons activity gets tired and wanes, and the I neurons resume firing, and the cycle just repeats itself. So then in eupnea, this oscillating pattern of neural activity is alternating between the I neuron and the E neuron circuits, and it produces a respiratory rhythm of about 12 breaths per minute. Okay. Then the next one is the dorsal. In the medullary center is the dorsal respiratory group, or DRG. It is one of the mechanisms that modifies this basic respiratory rhythm. It is a web of neurons that extends for much of the length of the medulla between the VRG and the central canal of the brainstem. So, all that. Now, we know we don't always breathe at the same rate, and breathing can be faster, slower, shallower, deeper. And so the DRG and other mechanisms modulate the VRG's activity. The DRG is in the integrating center that receives input from several sources. The DRG also issues output to the VRG that modifies the respiratory rhythm to adapt to varying conditions. Okay, and then the last group we have, and that's in the pons area, is pneumotaxic center, and it's part of the pontine group, or the PRG group. It receives input from higher brain centers, including the hypothalamus, limbic system, and cerebral cortex, and issues an output to both the DRG and the VRG. By acting on those centers in the medulla, it speeds up or delays the transition from inspiration to expiration, making each breath shorter and shallower or longer and deeper. The PRG adapts breathing to special circumstances such as sleep, exercise, if you're speaking, emotional responses like if you're crying, laughing, if you go for a run and you're needing to get extra breath in, if you're gasping, it is responsible for that part. So that's the basic rundown of the Respiratory Control Center, and I hope it has been helpful.